Hello everyone. In this video I will be working on question 19, the first question in that file for the end of term exam. So let f be a function defined on the closed interval from -5 to 5 with f of 1 equals 3. The graph of f prime, the derivative of f is given, not the graph of f. The graph of f prime, the first derivative. The graph consists of two semicircles and two line segments as shown above. In part A, we have to find all values x at which f has a relative maximum. We know that for the relative maximum, it has to be a critical point. That means f prime should be 0, and before that critical point, f must be increasing, and then the derivative is 0, and then decreasing. This is the function itself. So f prime needs to be positive, and after that point f prime should be negative. So if you look at the graph, f prime equals 0 at these points, -3, 1, and 4. But at which of these x values f prime changes from positive to negative, from above the x-axis to below the x-axis? So as you can see, it's happening at -3 because here f prime is positive above the x-axis, f prime is negative, and also at 4, f prime before x equals 4 is above and after it's below. So this is happens at x equals -3 and at x equals 4. So x equals -3, x equals 4. You can say that at those 2 points f prime equals 0, and before and after f prime it changes sign from positive to negative. This is the first part. Now the second part says find all values x at which the graph of f has a point of inflection. The point of inflection, we know that at the point of inflection f double prime equals 0 and f prime changes from increasing to decreasing, or f prime changes from decreasing to increasing. Why? Because when f prime changes from increasing to decreasing, that means f double prime changes from positive to negative. Or when f prime changes from decreasing to increasing, that means f double prime changes from negative to positive. So when f double prime changes sign, we have a point of inflection. And if you look at the graph, this happens when f prime was increasing and then it's decreasing. So at x equals -4 also it was decreasing, and then it's increasing. So at x equals -1. And also here f prime was increasing, and then decreasing, so at 2. So the inflection points will be x equals -4, x equals -1, and x equals 2. Again, at these points f prime changes from increasing to decreasing, or vice versa, from decreasing to increasing. Because when f prime changes from increasing to decreasing, that means f double prime will change sign from positive to negative, or negative to positive. That's part B. Part C, it says find all intervals in which the graph of f is concave up and has a positive slope. Okay, let's see what does that mean. Concave up and positive slope. What does that mean? Concave up means f double prime is positive, and positive slope means f prime is also positive. F prime is positive, that means on the graph f prime needs to be above the x-axis, and f double prime is positive, f prime should be increasing. This is what it means. When f prime is increasing, that means f double prime is positive, that means the function is concave up. And positive slope means that the derivative, the first derivative is positive. That the first derivative is positive, that means f needs to be above the x-axis on the given graph. So let's look back at the graph and see where does this happen. So above the x-axis and increasing, it's here, above the x-axis, above the x-axis and increasing from -5 to -4, and also from 1 to 2. So if you notice, these two intervals are the things that we are talking about. So the first interval on which the graph of f is concave up and also has positive slope, they are going to be -5 to -4 and 1 to 2. So on these two intervals, the function is concave up and has a positive slope. Now going back to part D, where if you look at the solution guide, it involves integral, and integral is in unit 6. But if we use informal method to find the absolute minimum, let's start investigating the behavior of the function. So notice that here the function is the derivative is positive. The derivative is positive, that means the function is increasing. It will increase this amount. So the function is going to be increasing. This is -5, and then it will decrease because the derivative lies below the x-axis. So it will increase all of this amount. Okay, so it will go down, 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 down until 1 here. From -3 to 1, it's decreasing down, and then it will go up this amount, this area under the curve. This is the meaning of integral. Notice that this area is smaller than the previous one, the semicircle. So it will go up, but not as much as it went down. So it will go up, not as high as this point, and then it will go down this amount only till the end point, which is 5. So the lowest point is, sorry, this is 1, not -1. So it's going to be at x equals 1. So the absolute minimum happens at x equals 1. The value is given, f of 1 equals 3. So f has an absolute minimum of 3. Again, this is not the formal and the accurate way to do part D. It has to be done with integration, and the integration is in Unit 6 in AP Calculus. Hopefully that was clear. Good luck, everyone.